Everyone knows an asteroid killed the dinosaurs, but almost nobody knows what really happened to it. The Chicxulub impact left a massive scar on Earth, but also a mystery that continues to puzzle scientists. What really happened to the so-called dinosaur-killer meteor? For decades, the belief was that it simply struck and was gone. But new research reveals something far more complex, an asteroid from beyond Jupiter, made of carbonaceous chondrite, that not only caused destruction, but also turned the planet into a laboratory of life and death. Contradictory as it sounds, that's exactly where the controversy lies. What once seemed to be only a catastrophe may also have been the trigger for the greatest evolutionary turning point in history. Imagine yourself on the Yucatán Peninsula in Mexico, where today tourists wander among Mayan ruins and paradise-like beaches. What few realize is that beneath their feet lies one of Earth's greatest scars, the Chicxulub crater. This colossal geological mark, stretching more than 110 miles across, is the silent testimony of an unimaginable cosmic collision, the Chicxulub impact. What's most intriguing is that, despite the certainty of the event, no significant piece of the meteorite has ever been found. It's as if a cosmic visitor left its traces behind while hiding its very body. Science describes the asteroid as a true intruder from the depths of space. Some researchers even joke that it was an asteroid from beyond Jupiter, a rock that traveled unimaginable distances before striking our planet. Upon impact, it released energy greater than billions of nuclear bombs, forever reshaping the destiny of life on Earth. And yet, here's the curious part. Despite all this destruction, the object itself remained mysteriously invisible, as if a crucial piece of the puzzle had gone missing. This enigma fascinates both scientists and laypeople alike. Think of it like watching a movie where the final scene is obvious, Earth left devastated, but the villain disappears before the credits roll. Geologists believe the rock may have almost completely disintegrated, leaving behind only microparticles mixed into layers of sediment. And it's precisely within these particles that crucial clues have been uncovered, including fragments resembling carbonaceous chondrite, one of the oldest signatures in the solar system. The mystery still resonates in every study conducted at the site. After all, the absence of the meteorite's remains does not lessen the weight of the evidence. The Chicxulub crater stands as living proof of a cataclysmic encounter. But if the mark was forever etched into our planet, what about the immediate effects this collision unleashed on life and the global climate? The Chicxulub impact was more than just a collision, it was an instant spectacle of destruction. At the moment of impact, the atmosphere ignited, waves of heat swept across continents, burning everything in their path. Animals thousands of miles away felt its fury. Soon after, as if Earth had become part of a cruel experiment, came the so-called impact winter. Dust and gases blocked sunlight, plunging the planet into darkness. Imagine waking up and never seeing a blue sky again. Plants withered because they could no longer perform photosynthesis. Without plants, herbivores collapsed. Without herbivores, predators fell soon after. In a short span of time, more than 60% of all life on land vanished. The giants that once ruled, T-Rex, Triceratops, mosasaurs, and pterosaurs, succumbed almost suddenly. The scene resembled a global domino effect, but with no chance to restart the game. The consequences went beyond biology. Temperatures plummeted, transforming tropical regions into cold and hostile environments. It was as if the planet shifted from a scorching greenhouse to a deep freezer in a matter of months. This environmental chaos respected no boundaries. Seas, deserts, forests, all were struck with brutal force. There was no refuge, only temporary survival. And yet, even when all seemed lost, science shows that from this destruction came new opportunities. The impact cleared the way for smaller species to find niches that had once been closed to them. But before understanding how life reinvented itself, we must turn back to the origins of this cosmic intruder. Where did it come from and what made it so deadly? The cosmic killer was no ordinary wandering rock. Research suggests it was an asteroid from beyond Jupiter, originating from a distant region filled with primitive stones. This area acts like a vast space graveyard, holding fragments from the infancy of the solar system. The Chicxulub impact, therefore, was not caused by a young body, but by something with billions of years of history, a cosmic fossil in motion. Its composition was no trivial matter either. Evidence points to a carbonaceous chondrite, a type of meteorite that carries organic materials and extremely rare minerals. Imagine holding in your hands a stone that preserves secrets of planetary formation and, at the same time, had the power to trigger Earth's mass extinction. This duality, both creator and destroyer, is what makes it so captivating to scientists. The size of this intruder is staggering, between 6 and 9 miles in diameter. To put it into perspective, it's like launching an entire neighborhood at the planet at more than 12 kilometers per second, striking at a 60 angle. This combination of speed and trajectory amplified the impact's power, acting as the perfect blow to maximize destruction. It was a calculation of nature itself, as if written in a manual of catastrophes. Now that we know where it came from and what it carried, a new question arises. How did scientists uncover such solid evidence of this episode? The beauty of science lies in the details, and in the case of the Chicxulub impact, every fragment found acts like a piece of a puzzle. In preserved fish fossils, scientists discovered tiny glassy spherules, rocks melted and cooled after the impact. These animals swallowed the particles in the chaos of those first moments, turning their bones into time capsules. It's as if nature itself had archived evidence in a vault we are only now able to open. Another fascinating clue came from the markings on the bones. Growth lines similar to tree rings revealed that the impact happened during spring in the northern hemisphere. This detail may seem small, but it sets the scene. The planet was in the midst of seasonal rebirth when it was struck by the asteroid from beyond Jupiter. The image becomes even more dramatic, flowers blooming while the sky darkened forever. And then there's the famous chemical element, iridium. Rare in Earth's crust but abundant in meteorites, it appeared in geological layers around the world. This metal became an unmistakable signature of the event's extraterrestrial origin. It was as if the carbonaceous chondrite itself had left its fingerprint engraved on the planet. These discoveries are far more than academic curiosities. They confirm that this is not some vague theory, but an event recorded with almost surgical precision. Yet if fossils and minerals already tell us so much, imagine what was uncovered when scientists drilled thousands of feet beneath the sea, directly into the crater, searching for even deeper answers. In 2016, an international team of scientists took on the challenge of drilling into the ocean floor, right at the heart of the Chicxulub crater. They went more than 4,000 feet beneath the seabed in one of the most ambitious scientific operations ever attempted. Their goal was both simple and daring: to reach the peak ring formation and retrieve direct samples from the very site where the Chicxulub impact had reshaped everything. What they found down there was astonishing. The drilling revealed massive blocks of deep granite and heavily deformed rocks, forced upward by the impact. Picture this: materials that should have remained miles underground were ripped out and exposed in an instant, as if the planet had been turned inside out. Such a geological upheaval doesn't happen under normal circumstances, only when an asteroid from beyond Jupiter strikes with unimaginable force. Beyond the rocks, something even more intriguing appeared: evidence of hydrothermal systems created by the impact. The heated fractures allowed hot water to circulate, generating environments rich in minerals. Scientists realized that the collision didn't just destroy, it also built unprecedented conditions at the site. These systems may have acted as cradles for primitive forms of life, reinforcing the idea that the carbonaceous chondrite brought more than destruction. These discoveries reshaped how we view cosmic impacts. It was no longer just about explaining how the dinosaurs vanished, but also about understanding how life managed to carve out new paths amid the chaos. And it was precisely this pursuit that drove researchers to investigate in greater detail how the mysterious peak ring came to be. The peak ring formation is one of the greatest signatures of the Chicxulub impact, and its origin once seemed like an unsolvable mystery. Imagine what happens when a rock 6 to 9 miles wide, a true asteroid from beyond Jupiter, slams into Earth with brutal force. The collision was so intense that the crust and even the deep mantle behaved like liquid for a few fleeting moments, something almost impossible to picture. It was like watching stone flow as if it were water. This phenomenon triggered a spectacular effect known as rebound. Rock from the planet's depths shot upward, creating a tower nearly 6 miles high. But the structure didn't last. It quickly collapsed, scattering material outward and forming a circle of inner mountains, the famous peak ring. A violent yet astonishingly precise process, it now serves as a blueprint for understanding how giant craters form on rocky planets. The comparison with the Moon, Mars, and Mercury is inevitable. All of them bear craters with similar rings. The difference is that, in Earth's case, we have direct data thanks to the 2016 drilling project. This not only allows scientists to reconstruct the impact, but also to study how our own planet behaves under extreme conditions. And that is precisely what makes Chicxulub a natural laboratory unlike any other. Perhaps the most intriguing part is that, after such unimaginable destruction, this very ring may have served as a shelter for microbial life. The hydrothermal systems that formed there, enriched with minerals, could have offered refuge amid the chaos. But to grasp how the impact shaped life beyond geology, we need to look at the evolutionary consequences that followed soon after. The Chicxulub impact was not just the end of an era. It was also the turning point for the beginning of another. When the asteroid from beyond Jupiter struck Earth, it sealed the fate of the non-avian dinosaurs, but it also cleared the way for mammals, once small and discreet, to find room to thrive. It's fascinating to think that without this collision, we might not be here today to tell the story. Picture a world dominated by predators like T-Rex or giants like Triceratops. In such an environment, tiny mammals would have had little chance of evolving beyond basic survival. But after the impact winter, with dominant species wiped out, these creatures began to occupy the empty niches. In a sense, the Carbonaceous Chondrite didn't just destroy, it paved the way for the diversity of life we know today. Another fascinating detail is that not all dinosaurs vanished. A small lineage survived: birds. This means that when we see a sparrow or an eagle soaring above, we are witnessing the direct descendants of Earth's former rulers. This continuity reminds us that evolution doesn't follow a fixed script. It adapts creatively to radical change. The impact, therefore, redefined the trajectory of life on the planet. It shows us that chaos can also be the spark of renewal. But beyond biological evolution, the transformations reached even further, reshaping the global climate and altering cycles that would take thousands of years to stabilize. The Chicxulub impact was not just a split-second event. It unleashed effects that echoed for thousands of years. After the initial explosion and the impact winter, the planet entered unstable climate cycles. Dust and particles thrown into the atmosphere lingered for years before dissipating, keeping Earth shrouded in cold and darkness. It was like living through a never-ending winter, where even the tropics became almost unrecognizable. This climate shock not only lowered global temperatures, but also disrupted rainfall and wind patterns. Tropical forests shrank, deserts expanded, and the oceans underwent dramatic chemical shifts. Scientists compare this period to a natural laboratory, showing how a single asteroid from beyond Jupiter can reprogram the climate of an entire planet. It's terrifying and fascinating all at once. Current studies, such as those by the National Academy of Sciences, suggest that climate stabilization took tens of thousands of years. For us, it's almost unimaginable, entire generations of species being born and dying in a chaotic environment. This delay in the climate reset was decisive in shaping the future of life. Without such a prolonged challenge, natural selection would never have worked with such intensity. This long winter became an evolutionary filter. Only the most resilient organisms managed to adapt, opening the way for new branches on the tree of life. And it is here that the story begins to take on a hopeful tone. Even after such immense destruction, life not only endured but re-emerged in unexpected forms. After the Chicxulub impact, it seemed as though the planet had been condemned to a barren wasteland with no future. But Earth has an extraordinary ability to reinvent itself. In the hydrothermal systems created by the collision, water circulated through heated rocks, enriched with minerals. These environments, shaped by the peak ring formation, became true refuges amid the chaos, where microbial life found conditions to thrive. Scientists view these systems as natural incubators. It's fascinating to think that while the impact winter dominated the surface, microorganisms deep within the crater were already testing new paths. These niches resemble the hydrothermal vents that exist in today's oceans, places where life flourishes even under extreme conditions. It's as if the planet itself had safeguarded a plan B for survival. The connection with the Carbonaceous Chondrite is inevitable. The very celestial body that brought destruction also opened doors to new forms of life. Some researchers even suggest that such impacts may have been crucial for the emergence of primitive life during other moments in Earth's history. In this sense, the asteroid from beyond Jupiter was not only an agent of death, but also a catalyst for rebirth. This duality teaches us something profound. Every ending can carry within it a beginning. What seemed like life's final sentence became the foundation for a new evolutionary cycle. And that is why, when we look to the sky, we don't see only threats. We also see possibilities. After all, if a single impact was capable of transforming the destiny of the planet, what else might the universe be preparing? The Chicxulub impact forever changed Earth's history. It was a real event, proven by science, and its marks are still written across our planet. What once seemed like a distant mystery from the past continues to bring answers that shape our understanding of life and the universe. Had you ever heard about the asteroid from beyond Jupiter and the impact winter? Share what stood out to you in the comments, and subscribe with notifications on to keep getting content about the hidden secrets of science and history.